Okay friends, so today we will discuss one of the most important rearrangement reaction, that is benzylic acid rearrangement. Okay, benzylic acid rearrangement. Okay, so it is very important rearrangement reaction for your competitive exams in your JAM, NET, GATE, every competitive exam. Okay, so let's discuss what is benzylic acid rearrangement. Okay, so what is benzylic acid rearrangement? So in this rearrangement, 1,2 diketones are converted into benzylic acid. Okay, so in this rearrangement reaction, 1,2 diketones. Okay, so for example, mm, first of all we discuss introduction. Okay, so 1,2 diketones. Okay friends, 1,2 diketones, 1 comma 2 di diketones, or we can say these are also called as benzyls. Okay, benzils, or we can say. Okay, so 1,2 diketones undergo a base catalyst reaction called benzil benzylic acid rearrangement. Okay friends, so in this benzylic acid rearrangement we have 1,2 diketones. Okay, and these are converted into benzylic acid. Okay, so in the presence of a base catalyst. Okay, so this is the simple definition for benzylic acid rearrangement. Okay, so what is 1,2 diketones? 1 comma 2 diketones. Okay, for example, C6H5, C double bond O, C double bond O, C6H5. Okay friends, so this is 1 comma 2 diketones. Okay, so this is 1 comma 2 diketones. Okay, so this is the general naming. Okay, so this is also called as benzil. Okay, this benzil in the presence of base catalyst, for example KOH. Okay, and second H plus ion. So in the of base catalyst, okay, it converted into benzylic acid. Okay, so C6H5. Okay, C6H5 OH, C double bond OH. This is benzylic acid. Okay, this is benzylic acid. Okay, so this is the general reaction for benzylic acid rearrangement. Okay, this is 1,2 diketones. In the presence of base catalyst, this converted into benzylic acid. This is called benzylic acid. Okay, so let's discuss mechanism part. Okay, how it will come. Okay, so let's discuss mechanism. Okay, okay, so let's discuss mechanism. Okay friends, we, for example, we have benzil, 1,2 diketones. Okay, so C6H5, C double bond O, C double bond O, C6H5. Okay friends, and we have KOH, potassium hydroxide. Okay, so We know that K plus OH minus, okay, K plus OH minus, okay, this OH minus will attack to the electrophilic center of the benzylic acid. Okay, so we know that this is electrophilic to electrophilic center, and this is a symmetrical molecule. Okay, so this is also a electrophilic center, and this is also a electrophilic center. So OH minus will attack to the electrophilic center first step. Okay, then what, this double bond shift towards oxygen. Okay friends, clear? Then C6H5 C double bond O C OH, okay, OH, and C6H5 we have oxygen negative charge. Okay, this step is clear. Then after this, negative charge will again comes down, and this group will migrate towards this side. Okay, this C6H5 group will migrate towards this carbon, and this double bond shift towards this side. So this is the mechanism. Okay, so clear? Okay, next step, this negative charge coming down, okay, to the from this negative charge shift towards carbon, and this phenyl group, this is C6H5 is a phenyl group, this phenyl group migrates towards this carbon. Okay, so finally we get C6H5 C6H5. okay, so this phenyl group will shift towards this carbon. Okay, so this is O negative charge. Okay, and this is C double bond O and OH. Okay friends, so we know that after we have H plus ion. Okay, for example, this this we can say 1,2 hydride shift. Okay, this is also called as 1,2 hydride shift, or we can say proton shift. Proton shift. So we have here proton, one proton, so this proton will shift towards this oxygen. Then we get COH C6H5 C6H5 C double bond O negative, and final step we have H plus ion in our solution. So H plus ion attack to the this oxygen. Okay, so finally we get C6H5 C OH C6H5 C double bond O, and this is, so this is the benzylic acid. Okay, so this is called benzylic acid rearrangement. Okay friends, so this is the definition, and this is the mechanism. Okay, complete mechanism. Okay, let's discuss some important questions related this benzylic acid rearrangement. Okay, so let's take some examples. So in first step we know that for example CH3 C double bond O C double bond O CH3. Okay, so this is also an example of a benzylic acid rearrangement. Okay, so in the presence of OH KOH, okay, what will be the product? We know that in first step OH will attack to the carbon center. Okay, this OH minus will attack to the this side. Okay, so this negative charge shift towards oxygen, and CH3 C double bond O. Okay, C oxygen per negative charge, and this is CH3 group, and this is OH group. Okay, again this negative charge will come and this methyl group will shift towards this carbon. Okay, this carbon. Okay, so finally we get CH3 and this bond shift towards oxygen. CH3, C, oxygen negative charge, this is CH3. Okay, C, double bond O, oxygen, this is OH group. Okay, in this case proton shift will occur. Okay, we have this OH group and this proton will shift towards this oxygen. Okay, so CH3, C, OH and CH3, C double bond O, and this is O negative charge. Okay, this step is called proton shift. Proton shift. Okay friends, then finally in our solution we have H plus ion. Okay, this H plus ion will attack to the this negative charge, then we finally get CH3, C, OH, CH3, C double bond O, OH. So this is the final answer. Okay, so what are the conclusion part? So let's see, in this case CH3, C double bond O, C double bond O, CH3, it converted into benzylic acid, means CH3, OH, C double bond O, OH, and this is CH3 group. Okay, so what are the major difference between these two compounds? What are the major? These are the trick. Okay, so we find out the trick. So what are the major difference between these two products? You can say here, this is, so in this case this methyl group shift towards this carbon, this methyl group shifted towards this carbon, and this 1,2 diketones are converted into alcohol and carboxylic acid. Okay, so this is also called as carboxylic acid group, COOH group, and this is alcohol group. This is alcohol group. Okay, so this is the conclusion. Okay, so for we will take one more question. Okay, so for example we have this type of question. Okay friends, so this is C double bond O, C double bond O, and so this is the question. Okay, so this is KOH. What is the product? Find out the product. We know that in first case this OH group will attack to the this center. Okay, this, okay, OH minus first attack to the this side, and this will go, this double bond go to the oxygen atom. Okay, so then after we get C double bond O, C, oxygen per negative charge. Okay, and this will come. So this is the product. Okay, again this negative charge coming down, and this group will shift towards this carbon, and this bond shift towards this side. Okay, so then after we get C, oxygen, and this is also okay, so this is this 5 membered ring and this one negative charge. Okay, one OH group will present. Okay, so C double bond O, this is OH group. Okay, so after proton shift C OH C double bond O OH. This is the final product. Okay, so these are the some examples related benzylic acid rearrangement. Okay, so in this case we know that these are two ketones are converted into alcohol and carboxylic acid. Okay, so okay, one more example. For example, we have this type of structure. Okay, okay friends, so this is also a example of benzylic acid rearrangement. Okay, so this is 1,2 diketones and KOH and second position H plus ion. Okay, so this is the concept and this is the answer will come. Okay, so we know that first of all OH minus will attack to this side. Okay, so OH minus will attack to this side and this negative charge, this double bond shift towards oxygen and again it comes down, then this group or we can say this bond shift towards this carbon, means here 6 membered ring is converted, membered ring is into 5 membered. Okay friends, so this is 6 membered ring is converted into 5 membered ring and this is OH group and this is COOH group will be changed. Okay, so this is the final product. Okay, this is the final product. So these are the some examples of benzylic acid rearrangement. Okay.